The ground trembles before you see it. Not an earthquake, not thunder rolling in from the ridge. Something deliberate, something scheduled. A trembling that comes every 47 seconds, as reliable as a heartbeat, as merciless as one. You smell it before the tree line breaks sulfur and char and something older, something without a proper name in any language spoken by men who sleep in beds. The sky above the valley has its own weather now. Clouds that do not move with a wind. Clouds that are the wind, punched upward through a throat of iron and fire at temperatures that would reduce glass to liquid and bone to vapor in under 3 seconds. Then you see it. 900 feet of stacked masonry, rivet plate, and furnace brick rising from the valley floor, like something the earth itself tried to expel and could not. The blast furnace at full operation. The great smelting engine of the industrial age. A machine so large that men who worked inside its shadow for 20 years could never fully describe its shape because no single human position offered a complete view. You had to be a bird, you had to be God, or you had to be on the payroll of the syndicate that built it, sitting behind clean glass in a city 300 miles east, watching the production numbers climb. In the year it reached peak capacity, this furnace consumed 1,200 tons of iron ore every 24 hours. It exhaled carbon monoxide in quantities sufficient to render an entire city block unconscious within minutes. It generated enough residual heat to warm 4,000 homes, heat that was vented, wasted, poured into the sky above a town that froze every winter while the furnace burned beside it. The towns nearest to it lost their orchards first. Then their wells turned the color of rust. Then their children began to cough in a particular way, dry, rhythmic, unproductive, that the company physicians called catarrhal, inflammation of the upper airways, and the mothers simply called the iron cough. And still, the orders came in. Rails for the transcontinental lines, structural beams for the suspension bridges, plate steel for the warships. The furnace did not care what it was building. It only knew how to burn. This is the story of what happens when a civilization decides that production is a moral virtue and builds a monument to that belief 900 feet tall. Every civilization that has ever pulled wealth from the earth has faced the same silent negotiation between what the ground can give and what the people above it can endure. The blast furnace did not invent that negotiation. It simply scaled it beyond anything previously imaginable. Here is the paradox at the center of this story. The same engine that built the modern world, its bridges, its railways, its naval arsenals, its hospital frames, its cathedral spines was an engine that consumed human beings as steadily and as efficiently as it consumed coke and limestone and ore. Not metaphorically, not in the language of labor theory or political abstraction. Literally, in measurable units, in shift lengths, in lung capacity, in years subtracted from a working man's life with the same precision the accountants used to calculate tonnage output. The men who designed it understood this. The men who financed it understood this. The ledgers were explicit. Injury rates, mortality figures, replacement costs for skilled furnace operators, all of it recorded, all of it budgeted, all of it accepted as the ordinary arithmetic of industrial production. The question this story asks is not whether the furnace was evil. Machines are not evil. The question is simpler and more disturbing. At what precise moment did the people with the authority to slow it down choose not to? And what did the world they built on that choice look like from the valley floor, where the smoke never fully cleared and the ground trembled every 47 seconds and the children coughed through the winter? That is the question the furnace left behind, still unanswered, still burning. By the middle of the 19th century, the industrialized nations of the Western world were starving for iron, not figuratively. The hunger was structural, architectural, civilizational. The railway networks expanding across North America and continental Europe required more rail stock than the existing forge systems could produce. A single mile of standard gauge railway track consumed approximately 120 tons of finished iron. The transcontinental lines being surveyed across the American interior would require thousands of miles of it. The mathematics were unforgiving. The old methods, the regional forge, the small furnace, the craftsman's hearth could not answer them. At the same time, the cities were growing vertically. Architects and engineers were drawing buildings that could not be built in stone or timber. They needed structural steel in quantities and consistencies that only a new kind of furnace could guarantee. Bridges were failing. Cast iron, long considered adequate for span construction, was revealing its brittleness under dynamic load. The D Bridge collapse of 1847, the Tay Bridge disaster of 1879. Each catastrophe sent the same message back to the foundries. What you are producing is not strong enough, not consistent enough, not enough. War accelerated everything. Naval programs on both sides of the Atlantic demanded iron plate of increasing thickness and reliability. A warship's armor in 1870 required rolling mills and furnace capacities that simply did not exist a decade earlier. The world needed a machine it had not yet built, and the capital to build it was accumulating in the hands of men who had very few reservations about the cost. The man most responsible for making the great furnace possible did not work in a foundry. He worked in a laboratory. Henry Bessemer's 1856 converter patent changed the arithmetic of steel production permanently. By forcing pressurized air through molten pig iron, Bessemer's process burned off excess carbon in minutes rather than days. What once required weeks of skilled labor now required 18 minutes and a single operator. Output per furnace multiplied. Cost per ton collapsed. And the blast furnace, already large, had justification to become enormous. Capital moved immediately. Syndicates formed in Pittsburgh, in Sheffield, in the Ruhr Valley. Land was purchased in river valleys where ore, water, and coal could converge. Engineers were commissioned not merely to build furnaces, but to build furnace complexes, integrated systems, where raw ore entered one end and finished rail stock emerged from the other, continuously, without pause. By 1880, the largest furnaces in operation stood over 90 feet tall and produced 300 tons of iron daily. Within 2 decades, that figure would triple. The race had no finish line. Every record established became the new baseline. Every engineer who designed a larger furnace was celebrated. Every syndicate that financed one grew wealthier than the last. The 900-foot configuration was the logical endpoint of that acceleration. Not an anomaly, not an excess, simply the inevitable conclusion of 30 years of unrestrained industrial ambition meeting the unlimited appetite of a modernizing world. To understand what the furnace actually was, you must understand what it actually did. Raw iron ore hematite, magnetite, limonite entered the furnace throat at the top. Simultaneously, coke and limestone were charged in carefully calculated ratios. The coke burned. The limestone acted as flux, bonding with impurities in the ore, drawing them away from the iron as liquid slag. The iron, heavier, sank. The slag floated above it. At the base of the furnace, Tuyer's iron nozzles arranged in a ring, blasted preheated air into the combustion zone at pressures exceeding 45 pounds per square inch. This superheated the interior to approximately 2,800 degrees Fahrenheit. At that temperature, iron ceased to be solid, ceased to be predictable, ceased to behave like anything a man could safely approach without full awareness that one failure in the system meant instantaneous death. Every 6 hours, the tap hole at the furnace base was opened. Liquid iron poured into sand molds or directly into ladles weighing 80 tons when full. The slag was drawn off separately, cooled, crushed, repurposed as ballast and construction fill. The furnace never stopped. It could not stop. Cooling a blast furnace prematurely cracked the lining. Shutdown was itself a form of destruction. The machine, once lit, demanded to keep burning. The engineers designed it that way. The financiers required it that way. It ran continuously for years at a time. The furnace had a secret the engineers recorded and the financiers buried. Furnace brick fireclay refractory lining degraded under continuous operation. Every engineer who had studied thermodynamics understood this. At 2,800 degrees Fahrenheit, sustained over months without interruption, the lining thinned, millimeter by millimeter, invisible from the outside, undetectable without shutdown and internal inspection. Shutdown cost money, therefore inspection was deferred. The thinning lining was not the only danger. Carbon monoxide accumulated in the furnace stack in concentrations that fluctuated unpredictably. Ventilation systems, where they existed, were inadequate by design. Adequate ventilation required space, and space cost construction capital. The gas moved silently, colorless, without warning. Men working the upper charging platform had no reliable instrument to detect it. They had only each other, watching for the man who suddenly sat down without explanation, whose movements slowed, whose face went the particular gray that experienced furnace workers recognized and feared. Scaffolding surrounding the upper stack was constructed for access, not safety. Platforms were narrow. Railings were absent on working faces where railings interfered with charging operations. The companies knew the mortality figures. They published internal reports with careful, neutral language. Accidental contact with molten material, asphyxiation due to gas accumulation, fall from elevated platform. The language was engineered to sound like misfortune rather than consequence. It was not misfortune. It was the designed operating condition of a machine that was never meant to stop. A furnace worker's day began before dawn and did not end at dusk. The standard shift in the peak production years ran 12 hours, 6 days per week. On the 7th day, when shifts rotated, a man worked 24 consecutive hours on the long turn, so that the furnace could maintain its unbroken rhythm without a single hour of reduced output. The machine's continuity was the organizing principle of every human life within 3 miles of it. The heat near the tap hole during casting reached 140 degrees Fahrenheit at worker level. Men wore wooden-soled boots because leather soles burned through. They wrapped their forearms in strips of burlap, soaked in water that dried within minutes. They drank prodigiously salt tablets distributed by company nurses, not out of care, but because dehydrated workers collapsed, and collapsed workers interrupted production. Housing sat 400 yards from the furnace perimeter. Company housing. Rent deducted from wages before the envelope was handed over. The glow of the furnace was visible through bedroom windows at every hour. Children in these houses grew up believing that orange sky was simply what night looked like. Wages averaged $1.40 per day in 1892. A skilled keeper, the man responsible for managing the taff hull and reading the furnace's internal condition, earned $2.10. The company's daily profit per furnace that same year, $4,300. The arithmetic was not hidden. It was simply never discussed within earshot of the men who lived inside it. The break came on a Tuesday morning in July. Shift change, the moment of maximum vulnerability. The refractory lining on the furnace's eastern interior face had thinned to 11 millimeters less than half an inch of brick between 2,800 degrees of liquid iron and the structural shell of the furnace itself. Internal inspection records showed the last measurement taken 14 months prior. The intervening months had not been kind to the brick. At 6:14 inches the morning, the lining failed. Liquid iron breached the shell at mid-stack height. It did not pour. It erupted pressurized by the blast air still driving through the tuyères below. It sprayed in an arc spanning 60 feet, reaching the adjacent charging platform where 11 men were beginning their shift. 7 died within the hour. The remaining 4 sustained burns covering more than half their body surface. The furnace could not be shut down immediately. Premature shutdown risked a full stack collapse. For 4 hours, while men were carried from the yard, the furnace continued operating. Production continued. The morning's iron output was recorded in full in the company ledger. 3 days later, 1,200 workers walked out, not in grief alone, in fury. They had known the lining was failing. The keepers had reported it. The reports had been filed and forgotten in an office in Pittsburgh where no one had ever stood within 400 yards of a tap hole. The strike lasted 43 days. It was broken by Pinkerton agents and state militia. Not one demand was formally met. The furnace resumed full operation on a Thursday morning in September, under a sky the color of an old bruise. The strike changed nothing immediately, but it recorded everything permanently. Labor investigators documented the lining reports. Congressional testimony followed. By 1910, mandatory furnace inspection intervals were federal law in 7 states. The companies complied minimally. The furnaces kept burning. The towns nearest the great smelting engines took generations to recover. Some never did. Wells remained contaminated. Orchards never returned. The iron cough passed from fathers to sons like inheritance. The furnace itself was decommissioned in 1931. Its stack was demolished with controlled charges on a gray November morning. 3,000 people watched from the valley ridge. They did not cheer. They did not mourn. They simply watched the smoke finally stop rising, one last time above a valley that had spent 60 years breathing its exhaust. And then they turned and walked back toward a town that was very quiet and very still, and would spend the next century learning what it meant to exist without the trembling. The ground, for the first time in living memory, did not shake.